Before we start looking at scene lighting, it is time instead to talk about normals. What are normals? Imagine normals as perpendicular lines to the faces of our objects. We can visualize them by going into edit mode. In this case, we see our whole wall because we haven't actually applied modifier. And by going into the mesh edit mode overlays menu that we find here at the top right, we can go and select precisely the normals that we want to visualize. Let's enable all of them. Vertex normals, edge normals, face normals. And let's increase their size to display them better. Let's set, for example, a value of 1. Here you see these are lines perpendicular to the faces, perpendicular also to the direction that individual edges and vertices have. These directions are used by Blender to figure out, meanwhile, what is the direction of the faces, to figure out whether a face oriented one way or another. If we now switch to wireframe view, we see that the lines are not even inside, but they are only towards one direction, and they also allow Blender to figure out how to shade our elements. Let's go look at the vault, for example. You see, let's isolate it with the A key. You see how there are all these lines going to tell Blender the different directions. If we select everything with the A key and go to the mesh menu, we find the normal submenu. If we call up the flip command, for example, we're going to reverse the direction of the normals. Let's do this as an experiment. You see that the normals have been turned the other way, but we also got that the thickness of the vault went inward. So if we now go into the solidify modifier, in order to get the thickness of the vault outward from +1, we have to go to -1 because the normals have reversed. So always remember, every face has its own side, kind of like playing cards. We have an outer side, an inner side, and the direction of this face is given by the normals. Let's go back to calling the flip command to have the normals outward again, and I'll also point out that I could also theoretically select a single face and go to reverse the normal only of this one. Look what happens. You see, this formation looks like a mistake. How come I no longer have my continuity in the thickness of the vault? Because there is an inverted normal. So one of the operations that you have to do when we have seemingly unsolvable problems, because let's see, I mean, how is it possible? Everything is perfect, everything is correct, and yet the modifier doesn't work. Here, one of the operations we always have to do is select everything, and with the keyboard shortcut Shift+N, we tell Blender to recalculate the normals. He automatically goes and looks at all the directions of the normals of the faces, sees that one or more than one are reversed from the others, so he automatically goes and adjusts them. So when you find yourself with seemingly unsolvable problems, try recalculating normals. This is done with Shift+N. Mark it down because this is one of 3 operations that must always be done to solve 99% of problems. One is to apply scaling, the other is to recalculate normals. The third one we'll see later, which by the way is to eliminate duplicates. Good. These normals, however, are also useful in other areas to understand how Blender helps us visualize our objects. You see that right now we see the individual faces of our vault, but we would like a smooth, non-faceted vault instead. Well, there is an option to tell Blender to display this object in a smoothed manner. Let's exit Edit mode, right-click, and click on Shade. Smooth. You see that now the faces are smooth, even though actually this strange halo has formed. But why do we see them smooth? Has something changed in our geometry? Let's go into edit mode and see it. Something has changed, but the geometry is still the same. That is, we always have these faces that go to create the vault. What has changed is in the normals. Take a good look. Now I right-click again and go to select Shade Flat, which is the opposite of Shade Smooth. What actually changes? It changes that while the normals of the faces are always the same, the normals of the edges and vertices are merged together. Look, I call Shade Smooth again. See? Some normals have disappeared. It simply means that we told Blender of averaging the position of the normals and then calculating the way light bounces off the surface of our object so that we can see it blunted. On the other hand, we have this strange halo that has formed that we might not like. And even the edges of our vault we would still like to see alive. Here we are helped by an additional modifier. We look for smooth. Smooth by angle. Why is it part of the normals group? Precisely because it is a modifier that goes to affect the position of the normals. We are not modifying the geometry of our vault, only how the normals are moved. Smooth by angle. Let's go and select it. We see that already immediately something has changed. Now we see the vault, we see it smooth, while the edges and end parts are well cut, because that this modifier goes to create a discriminant, i.e. says all those faces that go to form an angle of less than 30 degrees we need to see blunted. Instead, those that are closer to a right angle over 30 degrees, we want to see them clearly visible. Here then is where this modifier allows us to discriminate between the faces of the vault and the faces instead of the cut part of the arch. Let's press the Cache key again to display everything again, and let's go apply the shade smooth to our arc as well. We always have these bevels, these shadows, and we can always go and add the smooth by angle modifier. However, we see that here in the inner part of the arch, we continue to see the faces, because actually the normals that go into affecting the visibility of this arc are not the ones applied to our parallelly piped, but they are the ones applied to the cylinder that we were using as a boolean. So let's go to reactivate the collection bool. Let's select our cylinder, and with the right mouse button, let's go to call shade smooth. Here now our arc is also displayed in a beveled way. For the outer edge, on the other hand, we see just the individual faces to change this spec. Instead, we have to go and increase the number of faces that make up our cylinder. But let's leave it that way for now.